warahmatullahi wabarakatuh. We are from Team 4. Team 4 consists of Syafrudi, Riyad Seder, Ali Fatoni, and Shifa Usulani Asri. We're gonna show you about our discussion. The title is Humidity Analysis based on Weather Variable. In the first one, I want to share about the background. Humidity described as the amount of water in the air based on meteorological theory. When the daily mean of relative humidity is higher than 70, is caused by temperature change and overly saturated condensation phenomenon. Humidity sensor can be used for detecting the relative humidity in any environment. Humidity monitoring and controlling give the important roles in the production qualities, food security, and comfort in daily activities. In the electrical scope, humidity can affect various electricity devices in its life and the performance. One of the devices that affected by humidity is high voltage isolator. Electrical energy is transmitted and distributed from central power plant station to load center, use transmission and distribution lines. An insulator used to insulate the high voltage line inductor conductor with the body of the tower or pole body that is connected to ground. Insulator was affected by environmental condition. It's many environmental condition that affected the performance and the life performance, such as pollution, humidity, temperature, rain intensity, wind speed, and etc. The ability of an insulator was decreased because of that. Humidity and temperature have an effect on the leakage current characteristic of the insulator made of epoxy resin that filled with silica sand and silicone rubber without coating and with melamine layer. Measurement parameters are used to compare the analysis, the leakage current, and flash over voltage that occurs the insulator for various level of humidity and temperature. The data that the source that we use to our background is from Undip. You can look the source with this link. Okay, because of that, various factor affecting humidity is more than one. Not only temperature or humidity, but many various. In this discussion, we want to discuss about our discussion. We use multiple linear regression method, and the dependent variable is the humidity. The independent humidity is 4 parameters, such as is rainfall intensity, wind speed, the duration of solar radiation, and the temperature. Because of that, we know the importance of knowing what cause humidity to occur is important, and based on our background, we conclude the background in 3 points. The point 1 is the importance of knowing what cause humidity to occur is important, and the second, the controlling humidity and monitoring is also important, and the third background is the importance of knowing the factor that influence humidity.
So based on the things mentioned in the background, we conduct this project. And the purposes of these projects are: the first is to conduct statistical analysis on the factors affecting humidity, and we determine the factors as temperature, rainfall intensity, the duration of solar radiation, and wind speed. And this project is also to make the assumptions on the relation between each variables, and also to show the variables such as temperature, rainfall intensity, the duration of solar radiation, and wind speed affecting humidity. And the project benefits: we hope that this project could give the big picture on how temperature, rainfall intensity, the duration of solar radiation, and wind speed affecting the humidity statistically. And we also hope that we could give the recommendation for related parties in related fields to estimate the humidity based on those aspects. And for this project, we use the data collected by Badan Meteorologi, Klimatologi, dan Geofisika or BMKG, and we access the data from the website of dataonline.bmkg.go.id/access_data. And we make hypothesis for this project. The null hypothesis is that the temperature, rainfall intensity, the duration of solar radiation, and wind speed is giving no significant effect on humidity. And the other hypothesis is stated that the temperature, rainfall intensity, the duration of solar radiation, and wind speed is actually giving the significant effect to humidity.
Assalamu alaikum wa rahmatullahi wa barakatuh. In this section of my presentation, I will try to explain about the descriptive statistic that we have done related to the data, as the explanation of my friend earlier, that we will try to explain about the weather relation with the humidity according to some data that we got it from the website. And according to this descriptive statistic, I will try to explain about the summarized data for the descriptive statistic, while I divide my data into two sections: that about the general tendency for the middle value, that about the median and mean mode. And in the second part of this section, I will try to explain about the variation, that the summary of difference within the group. That's about the range, interval range, and variance, and the standard deviation. So in the first section, we have got the data related to the statistic that we in this section we actually use the SPSS program to take the output frequency distribution, and related to that we got some data related to it, and that divided to 5 sections actually related to it. So each part of the affection that affected on the main section that we have it about the humidity, it's the main section that we will talking about, because the affection of the weather always affect on humidity. So for example, the temperature, we make it as x1 in our system for the SPSS. So we get the efficiency of it related, as you saw in here for the graph, related to temperature affection of the humidity. And in this part we got for the average for the humidity, that we have in some section we have some missing data as explained before, but we try as much as we can to make the missing value are all zero. So in this part we got the mean for the average, for example, for the average temperature, and as 28,471. For the median we got different value related to the section as I explained before about the data that we have it. And in each part we have a different value related to this section, but actually maybe we have some error related to it because we have some missing value as I explained before. But for example, for the rainfall as the effect of a humidity, it it's the less value that we have it. And related to that, not always we have enough value to get a better humidity. So because the weather always the temperature when it's very hot, so the humidity will be very high. And when the rain also, when it's very high season of raining, it will be for the weather, the humidity, it will be very high. And as well for the duration of the solar radiation, that it will affect on the humidity. So it's always when we have a high solar radiation, we get a less humidity because when always the sun raised up, it will make the weather more dry rather than the previous one, that when there is a fall raining too much, we will get a high humidity value. And as well for the wind speed, it will affect on the humidity as well, because it will bring out some water from the air during to the section. But also when the average of the speed wind it high, it will give us a less value of the humidity. The second part as variation that I have talking before, it's about the difference within the group, not rather than for the whole data, but in one section of it. So we have the standard error mean and the standard deviation, variance, and the range. So for example, in our value in here for the data under the curve, that we have the histogram for the rainfall. Also, it's the frequency for each part and each section related to humidity. But rather than the previous slide, we got all of it related together. But in this section, we talking all about the difference within a group itself. So we got in here the average data for the for the rainfall, and we have in here the histogram of the temperature where it show that we have always a different data and different value related to the frequency. That because in each section of these we have a validation number. So related to that, we got a different mean and a different standard deviation as it's shown in the graph of the histogram that related to the variation. In here, as the explanation before, it's the same for the solar radiation for the X3 as we explained before, and X4 for the wind speed. But the data are always different related to the timetable that we take it from that website, that we use it for the Indonesian in the central in Semarang area. So related to this value, we get a different mean, different standard deviation, and but for all, as we try to explain, we got a better solution. Sorry. For the last part and last section of my explanation, it's about the analysis of variance, that we have the ANOVA in here. While we use the dependent variable as the explanation, it's the humidity average, and with prediction constant, the average, the temperature average, the rainfall, and the effect of solar radiation, and the wind section. So in this, for the ANOVA system, we use a significant value that it's 0.05, that it's 5% that related to the value that we have. And in here, it's the explanation time, the explanation ANOVA for each part, where it's the average of temperature, the rainfall, and the solar radiation, and the wind system. In here also we got a significant for each part related to it, and all of this data, as I explained before, we got it from the SPSS, um, for the SPSS program. I hope you enjoy it. Thank you so much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Shafrudi. I want to show you our interpreting and reporting result of the SPSS output, in this case with multiple regression analysis. In order to determine the relation between each variables that we use classical assumption test. And to use classical assumption test, we need to test the data before. One of the tests is normality test. If the data are normal distribute, the little circle will follow the normality line, and then we can look at this graphic. We see that the little circle follow the normality line, so the conclusion is the data are normal distribute. And then the next test is multicollinearity test. Check absence of multicollinearity using fifth value with coefficient table. Each value is below 10, indicating that the assumption is met. We see that this coefficient table in column 5, we see each value of the variable. All of this value is below 10, so the conclusion is no multicollinearity. And then the next test is heteroscedasticity test. There are no heteroscedasticity if the scatter plot doesn't have an obvious pattern. There are points equally distributed above and below 0 on the x-axis, and to the left and right of 0 on the y-axis. This is 0, this is for y-axis, and this is for x-axis. The little circle is not have an obvious pattern, so the conclusion is no heteroscedasticity. And after we make sure that our data can use the classical assumption test, and then we making for the decision. Making for partial t-test decision based on significant value. It say that when the significant value less than 5%, independent variable or x affect dependent variable partially. And then we see that this we look at this table, coefficient table, and this is significant value. The conclusion of partial t-test is temperature affect humidity, because this value is less than 5%. Rainfall affect humidity because this value less than 5%. The duration of solar radiation affect humidity because this value is less than 5%. And wind speed not affect humidity because the significant value of wind speed is more than 5%. And then the other hand, we making for partial t-test decision based on t-value and t-table. It says that when the t-value more than t-table, the independent variables affect dependent variable partially. For looking the t-table, we use this formula, and we use this is alpha. Alpha is 5%, divide by 2. This is 0.025, and n is our sum of data, and k is our sum of variable. We use 106 data and 4 variable independent, so we find this value on t table. This is 101, and with this 0.025. And then we look at coefficient table. Look at this t column. The conclusion of partial t-test with this t value and t table is temperature give a negative effect to humidity. We see the temperature, or x1, this is x1, have a t value mean 2.9. This is in negative area, and then rainfall give a positive effect x2. This is 3.4 in positive area, and the duration of solar radiation give a negative effect. This is x3 in negative area. Wind speed not affect, because x4 or wind speed is in this area. This area is not affect area. And then for negative and positive effect, it means for negative, if temperature is high and then the humidity is low. If positive, if rainfall high, the humidity is high too. Okay, and then making for simultaneous F-test decision based on significant volume. It says that when the significant volume less than 5%, the independent variables affect the dependent variable simultaneously. To know this statement, we use the ANOVA table and then look at this column, significant column. The value is 0.000, so 0.00 is less than 5%. So the conclusion is the temperature, rainfall, the duration of solar radiation, and wind speed affect the humidity simultaneously. Making for simultaneous F-test decision based on F value and T and F table. I'm sorry. When the F value more than F table, the independent variables affect dependent variables simultaneously. Then for determining F table, we use this formula. K is our sum of variable, and N is our sum of data, and then we find this value on F table. This. Then we can make the conclusion: the temperature, rainfall, the duration of solar radiation, and wind speed affect the humidity simultaneously, because we know that this F value is more than the F table. Okay, and then how big is the effect? To know how big is the effect, we look at this model summary table in R square. It has 0.445 or 44.5%. So we can conclude that x1, x2, x3, and x4 give 44.5% effect to y simultaneously. And then how about the effect of each variable? Okay, we use this formula beta multiplied by coefficient correlation multiplied by 100% to know the effect of each variable. And then we look at this table, the correlation table, coefficient table, and model summary. We get the beta in this coefficient table. This is for T average, or x1 is minus 0.25. That is. And then for coefficient correlation, we find in this correlation table, we need to find the correlation of temperature with humidity. This value is this. The value is this minus 0.473. This is, and then multiply by 100, and it's equal to 11.825%. We use this formula for each variable and get this value. And if we take a sum of this value, we will get this value. So this is such of division of this percentage. Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.